So one fire ranger station at A reports smoke 30 kilometers away. Reports smoke 30 kilometers away in a station at C due east of the first station 20 kilometers away. To the nearest 10th of kilometer, determine the distance between the two stations. Okay, so we have to draw a picture. I'm going to give you guys some scrap paper right now because this is one of the things that is difficult, is being able to draw a picture on your own. So try it on the scrap paper, and then I'll draw the picture for you and see how close you got. Now that we actually have the correct wording here, it'll be easier to draw. So station A, east 30 degrees north, so he's facing east 30 degrees towards the north. That would be the angle you would be looking at. No, I drew west 30 degrees north. There we go. Here's A, east 30 degrees north. We did this before with directions, yes. And he reports smoke. So I'm going to draw some smoke in here. There we go. Beautiful. 30 kilometers away. A second station at C, due east of the first station. So here is the second station at point C. Reports the smoke is 20 kilometers away. So we drew one triangle. Now, since the side opposite the angle is less than the adjacent side, this is the ambiguous case. There might be two triangles. So what we do is we draw a second triangle, still with the 30 degrees, with an obtuse angle. A, C, 30 kilometers, 20 kilometers. And our smoke's still rising up over there. Okay? So draw both your triangles. Triangle number 1, triangle number 2. Because the 20 kilometers could be so that all the angles are small, or the 20 kilometers could be so that you have one really big obtuse angle. Remember when we showed that that arm could swing around? That 20 kilometers could swing around and make this triangle where A and C are closer together. So we want to figure out how far it is between A and C. Can you see that we could use the sine law? The sine law says you need to know an angle and its opposite side, and what we could do is we could find angle C. So we'll do that first. So I want to find angle C, so I'm going to go sine C over 30 equals sine 30 degrees over 20. Multiply both sides by 30. 3 sine 30 degrees over 20. Without your calculator, figure that out to 2 decimal places. No, it's true. This one you could. Because 30 degrees is one of the ones you know. It is. It's 1 over 2. Good. So this is 1 over 2. What's 1 over 2? What's 1/2 times 30? 15. What's 15 over 20 reduced to? 0.75. Good. 3/4 is 0.75. If you don't believe me, 3/4 is 0.75, bring 3/4 to class on Monday. Give it to me and I'll show you. No. Now you're going to need your calculator. C will equal, but when I go to my calculator and I go sine inverse of 0.75, I get 48.6. Does it say to the nearest degree here? To the nearest tenth of a kilometer, so we're going to need to use all the decimal places. 48.6 degrees, or, since sine is positive, thinking about the cast rule, it could also be 131.4 degrees. Now, when we go to our pictures and we go back to our triangles we've drawn, does it actually work to write them both? Could I put 48.6 degrees? That's possible. It still doesn't add up to more than 180. And if I do 131.4 degrees, that triangle doesn't add up to more than 180. So both triangles are possible. Yes. Yes. So notice at the bottom of the page they have both answers listed. You know here this is, since the side opposite the angle is less than the adjacent, so the 20 is less than the 30, it's the ambiguous case. There might be 2 triangles. It's not guaranteed that there's 2 triangles.
Wouldn't it be the same thing?
See, when you swing this 20 around, this 20 could have also been right there, making this other triangle. You solve it the same way, but when we get to this point, when sine is positive, it could be, according to the cast rule, in quadrant 1 or in quadrant 2. So the angle in quadrant 1 is 48.6. The angle in quadrant 2 is 131.4. It is confusing. Well, what's going to happen right now is I've got my answers 48.59. One of the things I can do, I can store it, the store button above the on button. I can store it as X so that it remembers all of the decimal places. It is a nice thing to have. Okay, so let's solve for the distance from A to C in triangle 1. If I'm looking at triangle 1 and I want to find the distance from A to C, I'm going to need to know this angle. You ready for part 2? Okay. So how do I find out what angle is left? I'd have to go 180 minus 30 minus 48.6. So I could go to my calculator, 180 minus 30 minus, and instead of writing 48.6, since I stored it as X, I can just push X. And it remembers all the decimal places Isn't that nice? I stored my answer as x. When you get your answer, above your on button is the store button. So I know that that angle is 101.4. 101.4. And now I can use my sine law to find AC. AC over sine of 101.4 is equal to 20 over sine 30. Multiply both sides by 100, sine of 101.4. So we would have 20 sine. Instead of having to type all of this, your calculator also has an answer button. Have you used that before, above the negative? Second answer divided by sine of 30. 39.2. So we've got 39.2 degrees. And now we have to solve for the other one as well. 4 marks. Triangle 2. So now we go back up to triangle 2. I need this 131.4 degrees. How did we figure out that 141.4 degrees? There it is. If I would do 180 minus that answer minus the 30 degrees, 18.59. 180 minus those other two angles, the 30 and the 131.4. And in triangle 2, you do the same thing. AC over sine of, well, what's opposite of AC is 18.59. Is equal to 20 over sine 30. So AC so 20 times sine of my answer divided by sine of 30, 12.75, which rounds up to 12.8. So we got our two different answers. This is kilometers. For AC. Questions? Oh, 5, 6, 9, and 14. You can trash it, recycle it.